The current project that I'm working on basically has the requirement to encrypt any important information at rest or let it stored in the database. Lately, what I've been doing a lot of as well is like instead of say client needing to give you information or making information easily configurable, instead of using a Google Sheet where you're calling that API over and over, you end up having issues with the amount of times that you can call it, or you just have random issues with the Google Sheet not being accessible. It doesn't make things very reliable. So what I've been doing a lot of lately is using the data store. So any information from the spreadsheet, read the information, store it in the data store, and then you can use that data store to read it over and over again. That benefits multiple things because it fixes your Google Sheet API issues, but it also speeds up the whole scenario because the data store is crazy fast. So for this particular task, I had to encrypt the API key. Obviously, common practice anyway. But what a lot of other people do even is the API key, they'll store it in here in physical information. So they key it into their scenario as a variable and then just keep calling it, which is super bad because it means that if I need to, export my sheet and give it to somebody else as a scenario that they can look at or help me encode, or I upload it to AI or whatever I do with it, that API key is always in the actual code, which is super bad. So even as a basic implementation, you'd want to store that in the data store anyway, not in the actual code itself. So when it needs it, it gets it, reads it. But this method is even smarter again because it's storing, it's encrypting it, storing it, unencrypting it when it reads it back again. So just pretend this is any data. It can be data from an API or data from a database or data from a spreadsheet. Doesn't really matter, but I've just done them as variables. So pretend we use the name. This is the API key that we want to store, but we want to store it in encrypted method. This 256-bit key is basically just a variable that randomly creates an SHA 256 encryption key number. So every time I run this sheet, it'll create a new number. So the encryption is then stored with a different number every single time. So I'm not storing it with the same encryption key. So consider it like a password that's rolling all the time. All this information then goes into the database. So that's my test information. It goes over to the encrypt data. So if I go into encrypt data, you can see that the data into the encryption is the API key from my test data. The secret key is my 256-bit key that rolls over all the time. So it's actually using that to actually, password protect or encrypt the physical data. The encoding and the XML, just leave those as default. Base64 basically would do the files stored a little bit smaller than if you did, say, hexadecimal. So just leave it as base64. Data store, so all this is doing is just deleting the records. So if there's any records in there, I delete them just so we don't have any problems in the demo. In the data store, if I go into here, so the key is basically like an index record of each individual record in the database. Obviously, that needs to be different for every single record, and it can be anything you want. So if you're storing, say, people's names, people email addresses, people mobile numbers, and stuff like that, you could just use the name as a key. So it's using the name to actually store it all, as well as storing their name as well. It's like just class it as an index record, name or number. The information I want to store is name. So I want to store the name from my test data. I want to store the API key that's been encrypted in my encrypt module, and I want to store the 256 key, which is unencrypted. So this, you basically need to create a data store. So this is my data store that I just created for this test. So see how the key is storing as the name. It's also storing the name. It's storing the API key encrypted. See how it's a random lot of numbers that we don't understand. And then the 256 key is just the password that it's using to encrypt those numbers. The data is basically, if I go to the top, so name. So I want it to store name as the data structure. It's a required field, yes. I also want to store the API key, and I want this to be a required field as well. And then the 256 key, which is the unencrypted key that we use, say, as the encryption password. We also want this to be in the database, and we require that as well. So that'll basically mean we've got 3 fields that we can fill out. So in here, now we want to store the name, we want to store the encrypted key, we want to store the 256. So that's how it's getting this record information from me doing the data structure. And that's it basically for that one. So if I go run, so this is the key with a whole bunch of, with the numbers from 1 to 10 and then 10 to 1. So if I save it, run it, that runs all the way through. So you'll see in here that the output store, if I look at, the record. So name is the Peter, so we didn't encrypt that, so we can read that. The API key is some random characters. We can't read that because it's encrypted. And the 256 key, which is the password to unencrypt, is also in there as well. So then if we go over to the unencrypt one, so that's this one here. So it does it basically in the backward order. So you've got data store. So I selected the same data store. The filter basically says anything that's got a name in there, then show me those. Otherwise, if it's like a field that's blank, we don't care about it. So it just ignores any blanks or anything that doesn't have an actual valid name in the field. Then we go encryption key. So this is our encryption key. It's got that out of the database, that 256 random key. So we put that into here as our password. The unencryption key is obviously, we make sure it's the same setting. So base 64 UTF-8. The data that we want to get out of it is the database record that it's got out of the database, the API key that's encrypted. We want it to unencrypt using the 256 key, which I stored in this variable here. Then the actual physical data that comes out of it, now we can actually run it. This is just the test data. So this can go off and store it or do whatever you want to do with the data. But for this example, name, it'll store that because it's unencrypted straight from the database. The API key goes data store, unencrypted, then to this record. So if I run that, save it, run it. So you can see in here, so my output, so those two fields in this variable, name is obviously in there, Peter, and there's my API key with the random numbers and stuff in there. So to sort of show you how it works, I can also go back into here, change this to anything I want. All right, so this is the API key, hit save this, run it. So now that's stored in the database, the different information, the different API key, sorry. So now I can come into here, I can run this, save this, and run this as well. I go into my history, so my most current one that I've ran. And you can see into here, if I go to the very end, so the two things that read is name is Peter, which is unencrypted, and then the API key's been encrypted, then unencrypted in here. So this is an API key. So that's basically how data stores work and how you can encrypt data in and out of the data store. Hope this helps somebody.